Hello, my name is Salah Eslim. I'm going to do a presentation for my PRAC1 project on forecasting PM2.5 air quality in Beijing. This data analysis is scanned between 2013 and 2017 for 12 monitoring stations. It is included pollutant and meteorological condition. In our data from the 12 monitoring session, I select four of them to verify the environmental context and so the distribution of the air quality in different area. First of all, we will start for data analysis, for data handling for our data. We will connect our Google Colab to Google Drive to import the necessary data set for each station, and we'll do concatenate to get one file and merge it. We will import also necessary library for that. Now our data is merged and ready for exploratory for data analysis. We will understand what is our data is. This is our data here. It is 140,256 with 18 column. As we can see here, how's pollutant and meteorological. We have here also there is hourly and yearly the time. Here we need to handle it. This is our stations, how this is an important thing to discuss about it. There is here as we can see there is a missing value except the time, and we have data type, current integer and float, and there is an object, and we have to handle the object data type for analysis and for visualization, also for model building. There's a missing value. We handle it by and there is a percentage, and we have all less than 7%. We can handle it by mean, and except one direction we can handle it by mode. Here is a clear data set. Check here also set application. We'll do here also feature engineering for our set. As we said, we will handle data index. We will make all this data type to index to data index. This for time series analysis and sorting data. Also here create new features, so as here create weekend features, numeric features, wind speed category polluting category. There is a menu. We did many lag features. We did a lot of them. We will here go for visualization for our data. There is a statistical analysis visualization. Here we can see how it is distribution of pollutant per every station. As we know, there is for the industrial it will be as we expect. There is for the industrial to be higher, for suburban it will be lower, and all of them it will be the same, and there is a positive relation between except all three ozone, it is opposite to other, because when the temperature is increasing, there is the ozone increase as well, but for the other, it's that sign. Here is the distribution of the average pollutant level for each station. Has pie chart to show them. Here is a histogram. Here's it reflects high pollutant spike, and there is a variant of meteorological, depend on the season. How also there is here showing that this is a dry weather or defected sensor, but the low rain. As here also we can see overall trend over the time. More visualization here, but we will go quickly for the bivariate. Bivariate analysis. Here is the correlation between pollutant itself. Here we can see there is a strong relationship between PM1, PM10, SP2.5, and carbon monoxide. Here also PM10 with carbon monoxide. Here also some important things we can see between the pollutant and as we can see, if the temperature is low, the air quality, it is pollutant is high, it's hazard weather. But if you go with the high temperature, it's going to be low. You can clear here also for the weather rain. If it is increasing the rain, it will be go low. As wind speed, with strong wind speed, is going to also reduce the pollutant, and air quality will be better. Here is a good strong relation between PM2.5 and PM10 in all stations. Here you can see the winter is higher due to the winter activity, burning wood, heating system, is using a lot of fuel. Here, as with the strong wind friction, going to be low. Here's also the same different analysis. Here is, we can see it's later, it will be clear. Here's how is the pollutant monthly wise. As you can see, is in the summertime, it is low. Low pollutant percentage, but for the winter is going to be higher in all of them, except, as we said, is oscillate is diverse. Increasing temperature, increasing the ozone is mostly another visualization here. Multivariant analysis we can see. So in this, we can see there is a strong relationship between PO5, relationship between B pollutant and lagged features. Here is strong relation between meteorological as well as here. As we can see between meteorological and pollutant. Now we'll try to go quickly as we lost time. Here is also cover the outliers. For here model building and regression, here we will go a little bit fastly. We handle the data set. And for the important part in the data modeling, as I said before, I target PM2.5, and I use a 3 type of regression to for in our model, linear regression, decision tree regression, and K-neighbor regression, and did a comparison between them. First of all, we will split after choosing and targeting our column. We will split our data 80% to 20. Also, feature scaling for numerical value to check all. So we did the selection, as we said, comparison. We did a comparison between them. Here we, as after regression, there is we got a good values and accuracy. R square is 92% with root mean square error 13 with a good result. Training decision tree also is 95%. The lowest is Kennyport, but still is good. Also, there is a comparison between them, and as we can see, linear regression is the highest one, and we can do. This is also visualization for actual between and prediction for each regression. There is a for linear regression, as we can see, it's good line. As well as here, there is see the line per the time, all over the time. Here also we can see it is sample weeks. We can see also here, this is decision tree. Again, as a result, also here KNN. Now we will go for Streamlit application. Stream application, I run it to be ready. Oh, it's time out. Let me stop and we'll come back. And after running, I'll try to run it quickly, but I think it will take time. Okay, is it open? I divided my Streamlit application into 3 pages. So here we can see the data overview, how is the data, it is how many column, how many row. As we can see all of our data type. If you can see, need to see overview, sample, preview. Here also summary statistic for the data. Also here you can see a categorical column, like you can visualization graph, line graph. It's you can see how it is distributed. It's taking time. That's because of it's okay. For the heavy data, this is heating map correlation between them, as well as we can visualize this with the histogram. There's PM2.5 histogram. PM, you can see also. Taking time. It's working on. During There is a many challenging phase to it. Handling the missing value, feature engineering. We have to create heavy and large data, as well as we can see, and we can see also. Yes, here we can see scatter plot, like in 10. For the imputation for data, as well as doing the Streamlit, and I did a lot of model building and rebuild again. Like I choose first for the air quality index. After that, I work on I target PM2.5, as for me it's something critical to know it. Taking time here. So as this but plot also we can see it will take more times. Okay, here we can see also line graph. We will go to modeling and prediction. Yeah, so to handle also 90 column features, or features, it will be something giving a lot of errors. And like here I have we can select like PM10 for and we select the random forest. You can select which regression you need, performance, percent, actual. You can see actual and prediction, and also here coming here the line regression line plot. As I need to say that a lot of challenging I face, and there is a recommendation that is to build. Oh, there is one missing source. We also in our module we used GitHub, which has helped us too much to arrange our data, and you can record and you can getting back if for the previous code. Also, as well as manage and handle our data. This is a critical thing that we did. We can in the next recommendation we can go for AQI for the next if there is a time. Our work in someone need to work on this project, we can it's better to do more analysis as well as use another training model training using deep learning STM. That is thank you for this time, and thank you very much.